Today, our new chapter, derivative and mean value theorem. What is derivative? Of course you know, and only very few cases I tell you, if a function is of the form y is equal to phi of fx, function of a function, its derivative dy dx, derivative of the first function, that is phi dash of fx, then into derivative of it, that is f dash x. For example, say tan of x square plus x plus 1, its derivative, if it is y, then dy dx is equal to derivative of tan function, that is sec square of this x square plus x plus 1 into derivative of that part, that is 2x plus 1. Next, one thing I should discuss, if in a function of x is in power of another function, then like that, if a function is, say, y is equal to fx whole to the power phi x, with usual formula, etc., it is not possible to differentiate it. For that purpose, we have to first bring that function phi x here. For that purpose, take log. So log y is equal to phi x log of fx. From there, we can differentiate both sides with respect to x. Derivative of log y with respect to y is 1 by y. But derivative of log y with respect to x, it is 1 by y, this log function, so 1 by that into derivative of this with respect to that, that is dy dx is equal to, now it is product of two factors, so that its derivative is derivative of the first factor phi dash x into second function intact plus first function into derivative of the second part. It is again basically a log function, so its derivative is 1 by fx into derivative of fx, that is f dash x. Then dy dx, we have to obtain dy dx, then dy dx is equal to y into the whole thing. Y means this into the whole thing. This way we have to differentiate it. The next one is the Rolle's theorem. Suppose fx is a function such that it satisfies simultaneously three conditions. Number 1, continuous in closed interval AB. Number 2, derivable in open interval AB. And thirdly, fa is equal to fb, means functional value at this point is equal to functional value at the end point. If these three conditions satisfies together, then conclusion of the Rolle's theorem is there exists at least one value C between this A and B such that where f dash C is equal to 0. তাহলে the Rolle's theorem for a function phi x, it is such that number one, it is continuous over a closed interval. It is derivable at all points within the open interval AB, derivable. And finally, at endpoints, functional value and functional value other endpoint, they are equal. In that case, there must exist at least one point C, not exactly one, at least one point C in between A and B, such that f dash C will be 0. Next, suppose fx is equal to x square minus 3x plus 2. And interval AB is 1 to 2. Then the function is continuous in the closed interval 1 to 2. Continuous because it is an algebraic function having no denominator, so it is continuous everywhere. In that interval, it is continuous. Second one is it should be derivable. Its derivative is 2x minus 3. 2x minus 3. That function is continuous everywhere, so this function is derivable within 1 and 2. Then there exists at least one C within 1 to 2 such that f dash C is equal to 0. Now f dash x is equal to 2x minus 3. F dash C is 2c minus 3 is equal to 0. So C is equal to 3 by 2. At least one point is there within 1 and 2 where in that case C we get 3 by 2. Obviously it is within that where the function where derivative is 0. This is meaning of the theorem. Next, Lagrange's mean value theorem. If a function fx be such that function is continuous in the closed interval AB, the function is derivable in the open interval AB, then there exists at least one point C within AB such that f dash C is equal to fb minus fa divided by b minus a. Necessary condition that a function will satisfy Lagrange's mean value theorem is that it is first two condition of Rolle's theorem, and conclusion is that f dash C will be in Rolle's theorem. F dash C was 0. Here f dash C is equal to fb minus fa by b minus a. Very easily you can see that if fa is equal to fb, that is third condition of Rolle's theorem, fa is equal to fb, in that case this becomes 0. So f dash C is equal to 0. So it is a particular case. The next, let us take now few problems. First problem is the point on the curve x is equal to t square minus 1 and y is equal to t square minus t, where dy dx is equal to half. Options are 1, 0, 0, 0, 0, 1 and 1 and 1, 1. The problem here is one function is given. That function is in parametric form. That is, x is expressed in terms of parameter t, y also expressed in terms of parameter t. So if parameter is eliminated, then it is a function, it becomes a function of x and y only. So this is the function. We have to give, it is given that the dy dx is equal to half, then at which point of the function derivative become half. And because it is a parametric function, so dy dx can be obtained from dy by dt and dx dt. Dy dx is equal to that. Dy dt can be obtained very easily from there. It is 2t minus 1 by dx dt is 2t. Now problem become extremely simple, given that dy dx is equal to half. Therefore, we have 2t minus 1 by 2t is equal to half. Half cancels. So 2t minus 1, half cancels, it is equal to t. So that t is equal to 1. So if t is equal to 1, then dy dx is equal to half. Now when t is equal to 1, then you see x is equal to 1 minus 1, 0, y is equal to t is equal, putting t is equal to 1, 1 minus 1 again 0. So at the point 0, 0, the function have derivative which is equal to half. So 0, 0 answer, that one is answer. Yes. Next. Next problem is, if x cube y to the power 4 is equal to x plus y to the power 7, then dy dx is options x by y, y by x, x y by x plus y, x plus y by xy. These are the options. So here the given relation is between x and y. So this is not parametric, simple function. We have, from differentiating both sides, we can obtain dy dx, and the value of dy dx would be which one of the following. And because its powers are 3, 4, 7, etc. Better you take log on both sides. Log on both sides of the given function. Then it would be 3 log x base e plus 4 log y base e is equal to 7 log of x plus y, again log e. Now differentiate both sides with respect to x. It is log e x. So 3 constant, 3 into its derivative will be 1 by x. Because this is a function of x, its derivative with respect to x is simply log function 1 by x plus 4 into log y, its derivative with respect to x. It is 1 by y into derivative of that with respect to x, so that it is dy dx is equal to 7 into, it is a log function, so its derivative is 1 by x plus y into derivative of that part with respect to x. It is equal to 1 plus dy dx. Now we have to find dy dx in terms of x and y. So take dy dx into one side, this here, and there is another dy dx. So it is equal to 4 by y dy dx minus 7 by x plus y into dy dx is equal to 7 by x plus y into 1 minus 3 by x. Now simplifying, we get y into x plus y, 4x plus 4y minus 7y into dy dx is equal to x into x plus y, 7x minus 3y minus 3x, so that this become 4x minus 3y by y into x plus y dy dx is equal to 4x minus 3y by x into x plus y. Now you see, from denominator x plus y cancels, from numerator 4x minus 3y cancels, so that dy dx is equal to y by x, and this is answer. So second option is correct. Now next problem. If fx is equal to cos square x plus gx, where f of x minus 2 is equal to x square minus x plus 1, then g dashed pi by 2 is options pi plus 3, pi minus 1, pi plus 1, pi plus 2. Now let us see what is the problem. One relation between fx and gx. Fx is equal to gx plus cos square x, and fx is not given directly. F of x minus 2 is equal to that. So from there you have to find the derivative of function g at the point x is equal to pi by 2. So we are given that f of x minus 2 is equal to x square minus x plus 1. From there, very easily we can obtain fx. How? Now by replacing x by x plus 2, both sides. I replace x by x plus 2. So this become f of x means x plus 2 minus 2. So it become fx is equal to. Now here all are functions of x only. We have to replace x by x plus 2. So that x plus 2 whole square minus x plus 2 plus 1. So that it is equal to x square plus 4x plus 4 minus x minus 2 plus 1. So that it is equal to x square plus 3x. They together. And constant term is 2 plus 1, 3. This is fx. So from the given relation we get gx is equal to fx minus that. Fx is your this one, x square plus 3x plus 3 minus cos square x. So this is our gx. Now very easily we can differentiate. G dash x is equal to derivative of x square 2x plus derivative of 3x is 3. Constant, its derivative is 0. And cos square x, it is of the type cos x to the power 2. So its derivative will be 2 into cos x into derivative of cos x, that is minus sin x. So that it is equal to minus then 2 cos x into minus sin x. So that it is equal to 2x plus 3 plus 2 sin x cos x. Now put x is, we have to find g dash at the point x is equal to pi by 2. So g dash pi by 2, put x is equal to pi by 2 over there. So it is pi, it is 3, and cos pi by 2 is 0, so this becomes 0. So answer is pi plus 3. First option is okay. Next, next problem. If fx is equal to determinant of x plus 1, 1, x square e to the power x plus 1, then f dash minus 2 is options minus 2 plus 2, 3, and 4. Now here, if the function fx is given in terms of determinant form, we have to find f dash x and then put x is equal to minus 2. So to find its derivative, there are three ways. Number one, this is a second order determinant, very simple. You find the value of the determinant, it's a function of x, then differentiate. Or if it is a big one, then to find the derivative of a determinant, you can differentiate first row, all members of first row first, and other rows keep intact, plus differentiate the second row only, other rows keep it intact, and this way you get derivative of the determinant given in a bigger form, and in that case time will be saved. Now here, as because it is very simple one, it is x plus 1 into e to the power x plus 1 minus x square. Therefore, f dash x is equal to, this is product of two factors, so that its derivative is 1 into e to the power x plus 1 plus x plus 1 into derivative of this e to the power x plus 1 is e to the power x plus 1 into derivative of that part, which is simply 1. So we get that. Now f dash minus 2, we have to put x is equal to minus 2, so that it is equal x is equal to minus 2, so that it is equal to e to the power minus 1 plus x is equal to minus 2 means it is minus 2 means it is minus 1 into e to the power minus 1, so that its value is 0. And options are not there. So actually, its options are not that. Its options are 0. Okay, its options are 0. Fourth option is 0. So our answer is this. So now take the next problem. If fx is equal to log of x square plus x plus 1 base x plus 2 minus log of x plus 2 base 2, then dy dx at x is equal to 0 is, that is, dy dx means y is that, so it is actually, okay, take this is as y is equal to that, then dy dx at the point x is equal to 0. So actually we have to differentiate this first and then put x is equal to 0. This is the problem. So for log function, log x, its derivative is 1 by x provided base is e. Its derivative is 1 by x, 1 by that argument, if base is e. Otherwise, we cannot find derivative. So first of all, we have to change its base, this and that also. That is dy dx, y is equal to log of x plus x square plus x plus 1 base e. This is base x plus 2. So log of x plus 2 base e. This is equal to that. Minus log of x plus 2 base e by log of 2 base e. Now we can differentiate log functions because all log functions are of base e. Now it is now of the type u by v, numerator by denominator. It has a definite law for differentiation, and in this case the denominator is absolute constant one, so its derivative is very simple. Now dy dx for this part, it is derivative of this into denominator intact minus this intact into derivative of that part. So its derivative is 1 by x square plus x plus 1 log function. Its derivative is 1 by that into derivative of this thing, that is 2x plus 1 into log of x plus 2 base e minus, this is intact, log base e into x square plus x plus 1 intact into derivative of that is derivative of this is log of this, so its derivative is 1 upon x plus 2 and into derivative of that part, which is simply 1, whole divided by log of x plus 2, that is the denominator, its whole square, u by derivative minus its derivative. And one more thing is there here, log of 2 base e, it is also there, that is, this is in numerator, it would be log e base 2. Oh, I have not given the options. The options are log 2 base e, 0, 1 and log 4 base e. Now we have to put, derivative is completed. Now we have to put x is equal to 0. So dy at x is equal to 0, dy dx is equal to, x is equal to 0 means this is 1, this is 1. So 1 by 1 is 1 into log of 2 base e. X is 0, so log 2 base e. So this part is this minus, this is 1, log 1 base e is 0, log 1 base e is 0 multiplied by something, so it is 0 into divided by, one more thing, it is this into What is that? I am differentiating this. So its derivative is 1 by 2. Why it is here? This part is completed. This part. Now derivative of that. Derivative is this into this minus. Oh, derivative of, sorry, I have done some mistake. Just 1 minute. Its derivative is that multiplied by the denominator minus derivative of this part into that. So this is into its derivative is 1 by 2 whole divided by log x plus 2 whole square minus derivative of this part. It is a constant. It can be taken to the numerator by log e base 2. Log 2 base e in denominator. In numerator it would be log e base. They will be interchanged into derivative of that part log x plus 2 base e. So it is 1 upon x plus 2 into derivative of that part is 1. Now at x is equal to 0, dy dx is equal to, this is 0, 1 by 1 is 1, log of 2, log 2 base e minus, this is log 1, it is 0, log 1 means 0 into something is 0, by, this is log 2 whole square minus at it is equal to log e base 2, that is log e base 2. This is log 2 base e, and what is that? It is equal to log 1 log 2 base e cancel. So it is 1 upon log 2 base e minus log e base 2. This is equal to simply log e base 2. This is log e base 2. So this is 0. So 0 is answer. The next problem. Next problem is if y is equal to x to the power x to the power x to the power x up to infinite terms, then then 1 minus y log x into dy dx is options y by x minus 2y by x minus y square by 2x y square by x. These are the options. We have y is given in terms of x, and it is x power of x is x, its power is x, and up to infinite terms is there. So from there we have to find the value of 1 minus y log x into dy dx. Now the given function is, you see, y is equal to it is x to the power x, its power is x, again x. So if we count this one only, x to the power x to the power x, it is infinity minus 1, so that it is infinity. So it is x to the power x. Now taking log on both sides, log y is equal to x log x. Now differentiate both sides with respect to x, so that it is 1 upon y dy, 1 upon y, because it is log function, its derivative is 1 by y, into derivative of y with respect to x, so that dy dx is equal to, it is a simply function of x, it has two factors, 1 into log x plus x into 1 by x, so that it is equal to log x plus 1. So that log y is equal to x to the power y, x to the power, it is y, you see, this is x to the power, this is y. Oh. So 1 log y is equal to y into that, so that 1 by, now differentiate both sides with respect to x, 1 by y dy dx is equal to, its derivative is dy dx into log x plus y into 1 by x, so that it is equal to that. Now taking 1 by y into dy dx minus log x into dy dx is equal to y by x. Now simplifying this, 1 minus y log x into dy dx by y is equal to y square by x, so that we get 1 minus y log x into dy dx is equal to y square by x. So fourth option is correct. Okay. Let us stop today. If you think that this is helpful for you, then please share it and subscribe it. Next day we will take few more problems. Thank you.